Thank you. Good morning, everybody, and welcome to session 7. Today, we're going to talk to all of you about a very interesting topic, which is nature-based solutions. We have a great amount of presentations throughout the session, so please bear with us. We'll be together until 1 o'clock with a coffee break. So there's been a lot of recent developments. You'll hear a lot of projects, but also experimental evidence today. So we're very excited that we're going to cover a lot of discussion in terms of application, but also ongoing work. So welcome today to nature-based solutions for climate adaptation and mitigation from planning to practice. It is my pleasure to, together with my conveners, Fabio and Myron, to introduce the first talk. So the first one is Myron Peck. And Myron is going to be talking to us about implementing climate-ready marine habitat restoration, conservation, and lower trophic levels harvesting, examples from the EU Future Maris program. So without further ado, Myron, over to you.
Thank you very much for coming. First talk, last day. Great to see everyone. I'll be giving kind of a high-level presentation about this program that started in 2020. So I have some results to show, but not so many. And what I hope to do in this presentation is talk about what we're doing in the program. You're going to see, and you have seen, some more specifics about this from some of the speakers earlier in the week. That's black, that's not right. So Elena gave a talk earlier. Silvana, who just spoke, will give a talk in this session. So will Marie. Anna, one of our co-conveners, is next door, remarkably doing another session, and has a talk there. And now Fabio will also give a presentation. So you'll hear more details about some of the specific aspects in a second. So the nature-based solutions is a term that's being thrown around quite a bit right now, and there are different definitions. And we wrote a paper, a group of us, in 2023 that helped look at these different definitions, and most of them are very similar. The one that we're using, primarily because we are a EU-funded project, is this one. And it's solutions that are inspired and supported by nature, which are cost-effective, simultaneously provide environmental, social, and economic benefits that help build resilience. The three definitions are similar, but I think we'll hear a lot of differences in what people term nature-based solutions in the session, and that's certainly a discussion point. But for Future Maris, we're looking at three different solutions, right? So it's the restoration of habitat-forming species in coastal environments. It's the conservation of certain vulnerable species and habitats using marine protected areas. And it's what we term nature-inclusive harvesting. And what's important to look at on this slide is the bottom left, and the services and cultural benefits that these provide. And I guess the take-home message from this, before we jump into some examples, are that these three things are quite interrelated, right? And so the solution space needs to encompass all three of these things. So the program is big, and my job is challenging. It's looking from the Barents Sea all the way down through the Mediterranean, and also covering Belize and Chile. Lots of different habitats, lots of different contexts, lots of different species. But again, there's three different case studies, NBS 1, NBS 2, and nature-inclusive harvesting. But then there are these 40 storylines, and these are the regional applications. So storylines are not case studies, so when I say storylines, that's what I mean. So let's, and obviously this program can't be done. If you live in Europe, you'll recognize an acronym. If you don't live in Europe, you won't. That's okay. So there's a lot of different partners, and it's a team effort, it's a dream team, and so I'll go through some of what we're working on. So in terms of nature-based solution 1, restoration of habitats, we are moving from areas that have oysters and mussels. We're looking at kelp and macroalgae in very different latitudes, which is interesting. We have at least 3 different types of seagrass habitats. We have one storyline that's working on salt marsh. And obviously these areas and the ecosystem functions that these provide and services are coastal protection, carbon sequestration. Obviously blue carbon is a huge topic that we've been talking about this week. They promote biodiversity by forming habitats, and they're also very important for seawater quality and clarity. They clean the water. So these are very important habitats that promote biodiversity, and they're important for fisheries productivity, et cetera. So one example of this would be oyster reef restoration in the North Sea. I'm not old enough, but I guess in the past there was a huge oyster reef in the center of the North Sea. Do we want to get that back again? What are the aspects of carrying capacity if you have that many oysters out in the central North Sea? So we're doing some work to look at the biogeochemistry of these oyster beds in terms of carbon sequestration and other things. So we're doing some experimental work, but we're also doing some scenario planning of what does this look like in the future. And I think Marie will talk a little bit about mussels and some other aspects in terms of this nature-based solution. So effective conservation storylines, again, some of the same types of habitats. So it's not only restoration, but it's also just the protection of these habitats. So moving from kelp and macroalgae down through seaweeds and seagrasses. We also have work on charismatic species such as marine turtles. And when you have a species that depends upon different types of habitats, so coastal areas, sandy beaches, as well as offshore areas, then it's a challenge to promote conservation effectively, right? So we're tackling that. Also for diadromous species, the same holds true, where you have rivers and you have estuaries and you have offshore areas. So how do you do that effectively for the life cycle of the species? We also have some cool areas that, wow, I mean, I would love to go here. These offshore areas in Chile, we haven't had a project meeting there yet because of the carbon footprint, but I hope we do that at some point. But the aspects of climate refugia and climate hotspots, it's very important to recognize that some of these areas are warming quickly, and some might not be warming as quickly. And so where do we put these marine protected areas so they're effective in the future? Example of this would be a very small-scale example on Greek islands where community engagement is quite important, tourism is quite important. How do we effectively put these MPAs in place so that they are sustainable, so that there is enforcement and monitoring and things like that. So we're working at very different scales in the project, and this is an example where community engagement is particularly important and easier. So the third one, nature-inclusive sustainable harvesting. I don't have that much time, so I won't talk about how the reviewer of our project, we called this nature-based solution 3, and they refused to accept that. So we actually had to, our deliverable was not accepted. And they said, it's like hunting. This isn't a nature-based solution. But some would argue that it was, and we wrote that into our project proposal. I said I wouldn't say that because I don't have time, but I just said it. So anyway, that was upsetting. But so, yeah, obviously artisanal fisheries we're dealing with, but also industrial fishing. And very important is this lower trophic level, more sustainable aquaculture, right? So, and again, Marie, you're going to talk a little bit about that with mussels. Coming up with flexible adaptive management plans, multi-species approach, and recognizing the important cultural heritage that this provides. An example of this, a very challenging aspect is the nature and energy and food transitions that we want to go through. And in the North Sea, 25% of the North Sea will probably be covered by wind farms by 2050. So what space is left for fisheries? You know, how do we co-locate aquaculture? This is a huge issue that requires planning, and it has to happen now because these things are going. In the Dutch area, there'll be 1,300 turbines by 2030. So we're just running to catch up with the science that we need to plan how to do this. So we have a large case study that's looking at that in the North Sea. So again, the program, there are I list here 9 activities. More importantly, I list the folks that are in charge of these activities. I don't know after we leave the conference whether you're going to look back and look at the presentations, but please do so, because you'll find the contact information on here for the people that are doing this type of work. I want to go through just 2 quick examples of some of the activities that we've been doing. And filling gaps in knowledge, I mentioned some experimental work that we're doing. Obviously, we're looking at marine heat waves and the effects they have on some of these species. But we've also looked back in the past to see what's happened to these habitats. And earlier in the week, there was a presentation by Ernesto that talked about the CTI, the Community Temperature Index. So if we have temperature change, which we can document in these different European regional seas, the color red indicates the darker red, the faster the warming. What's been there in the past and what's there now? And so what can we plan in the future? How are these habitats going to change? And so we've done this for a variety of different time series and a variety of different taxa, and hopefully some of you saw that talk from zooplankton to benthos to mollusks and fish. And guess what? Things are changing. Things are becoming more tropical. We're losing cold water species in many of these areas. So what species should we restore or protect? So we have this information in hand, and it's important. And then to do the projections, we have CMIP6, and we have done statistical downscaling throughout every region, hopefully at a resolution that's appropriate, but that's difficult for some of the coastal areas. And temperature, you see here, sea surface temperature, dissolved oxygen, a whole session on that. So we provide these estimates for each of the storylines so that we can do projections, right? So species distribution modeling, et cetera, et cetera. And the one thing I want to point out is that the time slices now relevant for policy have changed. And so they really want to look at 2030 and not just 2050 and 2100. So, and that's challenging because climate isn't going to change that much by 2030. So, and obviously deoxygenation, this is just an example for the North Sea. I don't think I have to explain anything about scenarios or to this audience, luckily. So I'll probably be on time. And so then, again, there's a lot of different activities here from ecological functions and ecosystem services. We're looking at projective effects also on the level of food webs, and Marta will talk about a little bit of that in the Western Med. We have a lot of work on ecological risk assessments. 16 of the storylines have performed a consistent approach to look at ecological risk, looking at when you have NBS implemented and when you don't, and what the effect is for risks of those habitats and species and areas. So, yeah, a lot to go over, but I really hope that one of the reasons you come to these conferences is not to hear 5 days of talks in rooms like this, but it's to go out and discuss things, right? And so we have a chance now to compare our approaches, to talk about what's working, what's challenging, what's not, and so I really encourage you to go to our website. So you have 4 action items, all right? So your first action item is search for this. I'm not smart enough to put a QR code on the slide, so get involved, right, and register. We have 30 storyline documents that are on the website. Each of those storylines has a leader that you can contact. So we have work packages with science, and we have storylines that provide the regional context. So please reach out and take a look at the website. And I guess the other thing is that there's a confusing number of projects that are running right now. And they're all a little bit different, but they're tackling the biodiversity and climate change crises. Just in Europe alone, there's probably 12 or 13 of these things that are ongoing right now. So people like me have to figure out how to collaborate with other people like me in other projects. But globally, I mean, we're hearing a lot of different activities in a lot of different regions. So please take advantage of this session. And I know it's the last day, but let's talk about what we're doing and how we're doing it. Yeah. I'd like to pitch one project, Act Now, which is just started. That's looking at multiple stressors. So again, it's a slight variation on the work we're doing in Future Mares, but we're looking at how temperature and oxygen, and we've had a session on that already, so none of these topics are new to anyone. But I'd like to thank the Dream Team, right? So for all the hard work they've done, and we have about a year and a half left in the project. So the website will be a little richer with a lot of deliverables and science. And I'd like to thank you for your attention and for showing up on the last day for the first talk. And I have time for questions, which is kind of interesting. First time for everything. So thank you very much.
Thank you very much for that very nice overview of the EU Future Mares. I'm sure we will continue to talk about some of the nature-based solution examples and designs. Any questions? Yes? Could you tell your name and where you're from? Thank you.
Thank you so much for an awesome talk and super excited. Terry from the Arctic University in Tromsø. I'm interested a little bit because you mentioned it's expanding as far as the Barents Sea, and I'm interested if you're thinking of including sort of opportunities that might be arising, such as, you know, we've got these retreating glaciers, we've got sea ice removing, and so there are potential new habitats opening up for kelp species and other organisms that are storing carbon, and a potential expansion of these nature-based solutions.
Yeah, it's not all gloom and doom, right? So, I mean, there are certain opportunities that climate change provides, particularly for fisheries, when you're looking at new species that are coming in, and that's certainly part of it. But what we're trying to do is provide an evidence-based approach of what you might want to do in the future that might be different than what you did in the past. So, I mean, the other important aspect in your region and other regions is, you know, the financing by industry and things, how to get them promoting kelp restoration, urchin removal. So, yeah, there is some information coming in that space as well about new opportunities. And, yeah, so particularly when you have the ability to compare across latitudes. So kelp is another example where in Portugal, it's pretty warm. That's a southern distribution of some of these kelp species. We're up in Norway. And so just to make those comparisons, you know, can inform policymakers on what might work in the future and what might not. Yeah, thank you.
Great, thank you, Myron. Now we're going to come back to the room itself. We have another presenter. I don't know if anybody has any questions or comments. I think that overview from Elvira is a very useful summary of the benefits of nature-based solutions, but also creates further awareness of how indigenous communities can also help us with the local knowledge and information. But any other comments or suggestions? No? Okay, we're going to go back to the room then. So our next speaker comes all the way from South Africa, Lynne Shannon. Welcome. She's going to be talking to us about developing science-based actions to address South African marine ecosystem implications of the combined biodiversity and climate crisis. So without further ado, welcome.
Thank you. Thank you for having me. Today I'm going to present you with some reflections on science-based actions that address the combined crises, the combined climate and biodiversity crises. And I'll be drawing on the South African marine ecosystem for our examples, and on some collaboration with some wonderful colleagues in the three projects that you see mentioned there, One Ocean Hub, the Triatlas project, and the Belmont Exodus project. So to set the scene, it's important for us to consider what the working group, the combined working group on climate and biodiversity through IPBES IPCC, have put out in a report. And there they really made the case that stronger synergies are needed if we are to address the sustainable development goals, as well as the goals of UNFCCC and the Global Biodiversity Framework. And they really note that the cumulative global benefit of local measures for global level climate is really important, and to simultaneously address the biodiversity objectives. So if we move on to the Global Biodiversity Framework, it was accepted in December 2022, and it was aiming to put forward 4 goals and 23 action targets that would enable the 2050 vision of the CBD to be achieved. So the 4 goals, we're going to be focusing today on the first 2. Goal A, which is all around integrity, connectivity, resilience of ecosystems, and preventing species extinction. And then Goal B, which is focused on sustainability and on nature-based, nature's contributions to people. And then we'll be looking at the 23 targets and how we can address those. And these are really being encouraged for urgent uptake by 2030 so that we can reach the 2050 goals. So we've heard very nicely from Mavera about the IPCC Working Group 2 and its contributions to the assessment report. And here, I think what I really wanted to highlight today is the importance that they've raised of the feedbacks between what's happening in the future climate, the human or societal transitions, and the ecosystem transitions. And they're complex feedbacks, the impacts that occur, and it's a circular, in both directions, kind of situation that we're in. And ecosystem loss and degradation is at the risk of being exacerbated through climate change. And we really need to make sure that we are cognizant of that fact moving forward. Harris, in his Nature climate change publication, was looking at extreme events and showing that these have been really exacerbated as the climate has changed, and has alerted us to the fact that we can then be expecting to have possibly more regime shifts, and as the regime shifts, there are huge implications for society. We put together some expert inputs to the whole Global Biodiversity Framework process, and Paul Leadley led a contribution which specifically focused on transformative actions that are needed across all the drivers of biodiversity loss. And one of the key messages there is up here, the need for coordinated action across all scales. And I really like the wording that they used in that, so I'm going to read it to you. The degree of biodiversity change and the relative importance of drivers vary greatly across scales and from place to place. Drivers in one place can affect biodiversity in another. So the importance of scale, this is where we go down to the local level. So here you see South Africa, right at the tip of Africa. And really what we're looking for is locally meaningful actions. And we're looking for a mechanism that will integrate information from the local scales and integrate, disaggregate, unpack information so that we can measure progress made at national and at global scales. And to do this, we needing to look, as Pareto has pointed out, at indicators of ecosystem services and how these change over time. So what we did is we sat with some of the main conclusions from the IPBES IPCC workshop, and there were 41 conclusions, and we picked out some of the key ones that really addressed biodiversity issues specifically. And then we sat with the South African situation and with the science policy activities, and we tried to pair activities to each of those key conclusions. So that was the first cut that we made, and what we were seeing there is that many of the, and I'll just maybe read you one or two, many of the conclusions that have been highlighted are being addressed through ecosystem modeling and through ecosystem assessments. So if here you can see at the top there, we're looking at complex feedbacks between climate, biodiversity, and humans, addressed by ecosystem modeling. And if you look over here, the effects of nature and contributions to people, of spatial shifts in fishing as a response to climate change. So with that in mind, I just wanted to mention a couple of things on the science, and then we'll go to the policy, and then we'll go to some management. So in the Southern Benguela, we have been developing numerous models. You've heard about some of those during the week from Kelly Ortega. And what we've done there is try to put climate and climate change scenarios into those models and to look at how things are going to pan out for our biodiversity and for our fisheries in particular. And we have then developed indicator-based approaches to try to arrive at information in the form that decision makers can really use it. Then the South African team at SANBI has been regularly undertaking ecosystem assessments, and there's a National Biodiversity Assessment 2018, which is the most recent one, and there's a whole chapter on marine. And if you haven't had a look at it, it's available on the web. It's a fascinating read. The ecosystem types are mapped out, the way the sectors overlap are mapped out, and there's a wealth of information there. But we do have a lot of legislation in South Africa, and this is the new climate change bill, which is still in process. It's still being adopted, but it's really South Africa's first legislation that will address climate change mitigation and adaptation. And if we go on to a little bit more about management actions, and this is something, and I've put it here just so that I would encourage you later to go and have a look. It's a wealth of information. They have story maps going through storylines. They then basically are dealing with each of the issues related to climate resilience, and they're touching on what parts, it's done per municipality in South Africa, and they're touching on what parts of each of the settlements can be addressed, how vulnerable are they, how can we address those, what are the adaptation actions that can take place, and I'd really encourage you to take a look at that. So just hopping back a little bit to the legislation, and this is a paper that Kelly put together, and really highlighted how much there is available in terms of looking at climate with respect to fisheries in terms of litigation. Well, not always just litigation, but policy. And there's a lot of policy, and it's really how do we action that policy. So this is really getting to the nitty-gritty of the work we've been doing. And so I'll spend a little bit of time here. So what we did is we tried to identify, we took each of the targets, which we'll go through in a moment. We took each of those targets and we had a look at what are the either research, scientific research, or policy or management actions that are addressing those. So what activities, that's why we call them activities, what activities are we undertaking in South Africa that are actually speaking to those global targets at the national level? And in doing that, we're hoping that we can then start to build on this and have inroads into actual action. So let's just go through a couple of these here. We have 23 that we've identified, and there will obviously be more. But what you see here is each of the targets that are addressed by things like biodiversity management plans, climate smart marine protected areas, participatory decision making, ESG reporting. Look over here, we're having a look at extreme events analyses, South Africa weather forecasting, and up at the top here, just another one to pick out, regime shifts, time series, and modeling. And so you'll see these are all in the green sphere, which is biodiversity, because these are all, by virtue of the study, activities that are speaking to biodiversity targets. But what we then did is we went through and had a look at which ones are also speaking to climate targets. And more than half of them are, which is good. It's showing the codependence of the two and illustrating that we are, through our activities, addressing both crises at the same time. And so here is where I wanted to just go through a couple of the more interesting targets. And this is really very preliminary. It's just from our first cut. But basically what I wanted to show you here is that target 8, looking at the impacts of climate change, has a lot of activity in terms of research, or policy or management actions, management measures rather. And then we see also a lot are relating to marine spatial planning, to marine protected areas, and here to ecosystem connectivity and integrity, and then obviously the sustainable consumption. Yun Shin, she was leading a chapter of the Global Biodiversity Assessment and put a paper together here where she has shown, or they have shown, that the post-2020 action targets for 2030, addressed by various different biodiversity measures, these actions, these biodiversity measures, are simultaneously addressing climate change mitigation activities at the same time. So there are direct co-benefits. And what we would like to pose, and we'll be unpacking it a little bit more in future work, is that there are direct co-benefits of marine ecosystem-based management actions in the Southern Benguela in South Africa, that so there are direct co-benefits of what we're doing for the biodiversity for the climate. So hot off the press, this is a paper by Portner et al. That is coming out in Science Today, and I've been assured by Yun, who's a co-author, that I can show you this. So she sent it to us. So go and have a look at it. The climate crisis and biodiversity crisis cannot be approached as two separate things. So here they are basically presenting solutions to how we can address the climate and biodiversity crises while making sure that we mitigate the social impacts that are already very visible from both of these catastrophes that are occurring. And so on to the conclusions. We've seen that we have several South African global biodiversity framework target-based activities that are simultaneously addressing both climate and biodiversity crises. And most of what we've seen have a very strong social component. And that is a really key point I wanted to put across today. These activities are also simultaneously addressing the 6 outcomes of the ocean decade, and that is oceans and coasts that are clean, healthy and resilient, predicted, safe, sustainably harvested and productive, and transparent and resilient. So we're addressing all of those 6 ocean decade outcomes through what we are doing for the GBF and for the climate. So the question in South Africa and everywhere is really how are we going to action all of this really good intention. And in South Africa, we're very fortunate to have a history of science and policy working very closely together. But it's nonetheless going to be challenging, and I think it's a big challenge that we can identify with everywhere in the world. And then I just wanted to, last of all, leave you with further reflection. As the IPCC IPBase workshop pointed out, we need further reflection on how to explicitly consider biodiversity, climate, and societal interactions as we go forward with policy decisions. And here, I think there is a good opportunity to explore synergies between ecosystem approaches and between human right-based approaches. And then just last little point to remind you of Target 22, where we are encouraging participatory decision-making. And I think that's going to be key as we're going forward to everything that we're doing. So thank you.
Thank you. Thank you very much. Unfortunately, we don't have any time for questions, so please do grab a over coffee. We're going to have to move to the next speaker. Thank you. Very interesting presentation. Okay, so we move to the Western Mediterranean Sea. Next speaker is Marta Coll, and she will be talking to us about historical contributions of spatial measures to halt the impact of climate change and intense fishing in the Western Mediterranean Sea. Thank you, Marta.
Thank you very much. Can you hear me well? Okay,
Yes.
thank you. It's a pleasure to be here. I want to acknowledge my co-authors and also the conveners for choosing this talk. I'm going to bring you to the Mediterranean Sea, and I'm going to bring you to marine protected areas, so another nature-based solution in another region. What we have been doing here is testing what the historical marine protected areas have been doing in the Western Mediterranean, as a starting baseline for the work that we are doing in future mares. So very briefly, what is the Western Mediterranean? The Western Mediterranean is the west of the Mediterranean, clearly, but it's a very large area. It's about the same size of the Gulf of Mexico. So it's quite a pretty big area, hotspot of biodiversity, also hotspot of human activities. So it provides key provisioning and supporting services, but also has high diversified fisheries and important activities for the region. However, it's highly overexploited. It's probably one of the largest of exploited regions in Europe, and there's climate change is starting to have an impact there. So there has been a lot of talk, and there's a lot of marine protected areas in the region. Most of them are small, and most of them are not so much effective, or they have low level of effectiveness, but there's a lot of them. And there's now a lot of talk on how we modify them, what we should do with them, how we combine different management strategies. So our question was, okay, if we need to provide this future advice, we need to know what they have done in the past. What is our baseline? So we started looking at that. And here in this map, you see what are the marine protected areas historically, where are they? And you can see that in red, you have the fully protected areas. You won't see them in the map because they are very small and they are just few. In green and in blue, you have unprotected protected areas, so protected areas that haven't been protected. And the Natura 2000 sites are unclassified because they've never been really like a process to properly protect them. But they are all there, right? So we need to assess what has been their contribution. At the same time, we know that when we protect, or we want to assess protection, is not only size that matter, but it's also how efficient, or how effective that activity is, because we have that compromise. So there's small areas, but they have been highly protected. So we wanted to assess that. And we did it with an ecosystem model. So we went into marine ecosystem modeling approach. I won't go into the details here. You have been hearing a little bit about them, but they are very integrative platforms that allow you to bring in the data and information from the natural environment, from the human activities, and from the climate change, and are now more and more used to explore management scenarios on the climate change. So what we've done is we took advantage of EcoPath, Ecosystem, and Ecospace, which is an approach that is quite modular, and it allows us to bring in a lot of data, like spatial temporal dynamic data to drive our models. And especially we took advantage of the spatial temporal framework that brings in GIS layers of temperature, salinity, primary production, and also the habitat foraging capacity model, which is a model that allows you to combine full web modeling with niche modeling or species distribution modeling. We won't go into the details, but we can discuss later. And this is the whole workflow that I'll go very quickly because I want to show you the results. So basically, in the column, we built an EcoPath model, quite resolved, 93 groups, where you see all the dependencies there of the groups. We fitted the model with historical densities of data, and then we went into specialize the model. It has around 3,000 cells where the species are moving around. All this modeling framework took us around 2 years to develop because a lot of sectorial data and studies go into this modeling approach, so it's data hungry. It took a while, but now that we are ready to really start trying this to test the scenarios. So we are testing combined scenarios of fishing effort with spatial management and including climate. These are examples of the data that we are bringing in. So you have environmental parameters here where we have different possibilities to drive our models. And what I'm going to show you today is the results of driving the model with a biogeochemical JET-TEM MET ergon difficult model. It's developed by GRC at the European Commission, and it has the proper resolution for us to drive our model. But we are also going to be driving these models with future mares, the downscaling data, and hopefully with FishMIP data in the near future. Here you see examples of phytoplankton, small and large phytoplankton in the frame that we are studying to 2002, and then in the future, and time series of temperatures that are coming in, and also the time series of fishing effort that we're including in our model. And the last methodological part is to show you, okay, what scenarios we have tested. In this table, you see different scenarios, so 5 scenarios. We have the status quo, where we have all the MPAs that we have in the region. We have the fully protected areas that are close to all the fishing, the highly protected areas which are close to the most damaging fishing, and we have the MPAs, medium protected areas, poorly protected areas, unprotected areas. So this is a classification that a colleague did, and we just followed the classification and applied it to the status quo of the region. We also have one simulation with no protection, because we wanted to see what was the difference. And then we added 3 ones that we think that if we would have implemented them in the past, we may have made a difference. One is to put highly protection in national designated MPAs. Okay? The other one is to close Natura 2000 to impacting fisheries, and the other one is to combine the 2 of them. And the results I'm going to show you are results in terms of biomass and catch of the functional groups in the model, but also of aggregated indicators in terms of consumers, commercial biomass, predators. You have their fish, the elasmo branch, invertebrates, pelagic, demersal, etc. I'm going to show you results of the final versus the initial conditions of the model, and I'm going to show you comparisons between no protection at all with the status quo and with this alternative, what we call counterfactual scenarios, to what may have happened if this would have been different. Okay? And we are also looking at projected fishing effort, but I won't show it to you today. Okay, so these are the first results. Here you have all the functional groups of our model, and these are the biomass final over the biomass initial conditions for scenario 0, no protection, scenario 1, the status quo protection. The first thing that we notice here is there's quite a lot of things that have declined with time historically in the area, and that is validated with some data that we have. The second thing that we see here is that there's not so much difference between, or not at all in some cases, between scenario 0 and scenario 1, which means, yeah, I mean, those marine protected areas didn't really make a difference in the region, except for these 3 circles that you see here. Those are sardines, small and large sardines, groupers, and the deep water shrimp. Those seem to have benefited somehow with this protection. And this is a mean with the different scenarios of climate change. Okay? So what happened if we add those 3 scenarios that were a little bit more restrictive in terms of protection? We start seeing some changes, some dots that move, or there's less reduction historically, or there's some recovers for some species, especially we see in those groups that were already kind of benefiting from the MPAs that were there. We see that there's some invertebrates, those are invertebrate species that seem to be reducing when we put this higher protection. And I went into the species interactions, and this is because of the trophic interactions and of the trophic cascades in the model. And unfortunately, higher commercial species, those are hake and large demersal fish, don't seem to really react to this historical potential additional protection in the region. Here I'm showing you 2 contrasting results. Those are sardines, where if we would have implemented scenario 4, they would now be doing better than they are now doing today, which are declining massively in the region. But hake, like a very highly commercial species in our area, highly overexploited, would not have noticed. So two contrasting results. Okay, quickly, I go to the aggregated indicators. Here you see indicators of commercial biomass, commercial and predators biomass, elasmobranchs and fish. Those are the indicators that showed some significant results. But the first is to notice is there's really no change between S1 and S2, so the status quo and no protection, except for predators biomass in here, that we noticed that historically the MPAs that we had contributed somehow to this biomass of predators. So these are good news for me. And we also see that overall, when we check with the counterfactuals, they would react positively to this protection, but in this case, elasmobranchs would have declined. And this is also because of a trophic cascade and trophic competition for food with other predators that would be rebuilt. If we go to catch, it's a very similar result. We don't see basically results with difference between S0 and S1, except for predators and fish. And we also see this trophic cascade in invertebrates and in elasmobranchs. Okay, and what happens with climate then? So what happens if we compare the different climate scenarios? Okay, here you see values, again, for the same 93 groups, for the mean, the constant climate, and 2 scenarios of climate change. We see similar trajectories of climate with time, which means that overall, historically, it doesn't seem that climate was the real force in the changes that we saw. Although there's some changes in some groups, but mostly are moderately, lower moderately, and there is higher impacts on invertebrates. This is because our simulations are going from 1995 to 2002, but really the climate change is from 2016 to 22, so 7 years of reaction. So the ones that react the first are the invertebrates. Now we are doing this to the future and things are changing. Okay, and very quickly, the aggregated biomass indicators for climate show similar results. So there's really not a clear change between the scenarios. Okay, quickly I'm going to walk you through the conclusions. So what we can say historically, the MPAs that are in the region did not contribute to restore any of the resources except for punctual data that we have for predators and fish. We see that the counterfactual may have increased and may have benefited some, but the commercial species, highly commercial species in the area would not have recovered either. So historically, fishing had a much larger impact in the area than climate, and things may change in the future. Now we are projecting that. And trajectories were mediated by trophic interaction, so that's also important to realize. And I leave you with this. So we are working hard with these models. We are contributing with future matters, for example, testing the future scenarios. There was a poster about it, where now we are going to put this model to analyze different future. And with that, I thank you. Sorry, I spoke too much.
Thank you, Marta. A lot of really good results and really interesting outcomes there. So just have time for one quick question. Any questions or comments? Nope. I have a quick question. When you talk about the scenarios about the invertebrates, you said the next part of it, the invertebrates have already shown a response.
Yes.
Is this to do primarily with what type of invertebrates are we talking about? Polychaetes? Are we talking about mollusks? What groups of invertebrates?
We have
or is it just the...
Yeah, we have all type of invertebrates in the model, but the ones that were reacting the fastest were the planktonic ones and the shrimps, especially shrimps and zooplankton, the smallest ones. So okay. The ones that have a higher turnover.
Okay, thank you. I will catch you over coffee because I'm interested in that concept as well. Okay. Thank you very much, Marta. So just bear with us before coffee break. We have another very interesting presentation by Katriina Juva. She's going to talk to us about the future of Northeast Baltic Sea marine protected areas based on species distribution scenarios. Okay, welcome.
Thank you.
Okay.
Thanks for having me. Actually, I'm going to share with you two things. One success story, which would be the Northeast Baltic Sea marine protected areas based on species distribution models, so without the future scenarios, and the first glimpse then what is going to happen when we take into account climate change as well. So that as a context. To start with, this is basically the same talk that Marta gave, a little bit different area. We are in the northern Baltic Sea, so we are now somewhere here in Bergen. If you cross the Scandinavia, you end up in Baltic Sea. Here is Finland, and we are now talking about the Finnish waters, so the northern part of the Baltic Sea. And it's quite a unique area because there's strong environmental gradients, there's strong seasonal cycle, And most of the species that are there are already in their, at their limits of survival, so to say. So that in the northern part of the Baltic Sea, there is almost freshwater, so there's no salinity, more or less. And when you go to the straits, so the Danish area, there's like 20. The salinity is around 20. So it's already quite challenging for the nature to survive in the northeast Baltic Sea. And the question is how to protect the little that we have in the future and now. So as Marta showed, there are already some marine protected areas everywhere. Here is what we have in the Finnish waters. But as shown, those are not quite effective. So here are the little few dots here and there are the ones that are in place that have which are something else than lines drawn on water. So those are covering less than 0.4% of the total area. So how to do this smarter? That's the question. So what we have already done for the current climates and current species distribution is that we are taking the biodiversity data into account and try to figure out where are the current biodiversity hotspots. And we did this a few years back, and we got this nice map showing current biodiversity hotspots called EMMAs, which are national EPSAs. We did a data analysis, included the EPSA criteria, excluding the primary production because of the eutrophication situation at the Baltic Sea. And we included a huge amount of the underwater marine diversity data, over 170,000 observations, and contributed 10 species community distribution models, and also included fish distribution models, habitat types, bottom quality layers, and some anthropogenic pressures to create this map. And while it's great, this is the success story. Those were implemented to the Finnish Maritime Spatial Plan 2030, what was approved in 2020. So these areas were included to the Marine Spatial Plan almost as they are. These green ones. So that's great. So Finland is trying to take into account the underwater biodiversity in the Maritime Spatial Plan. But what about the future? What is going to happen with those beautiful biodiversity hotspots in the future when we know that the Baltic Sea is warming rapidly? There's an eutrophication problem, oxygen levels are getting lower and lower, and these beautiful biodiversity hotspots might end up looking something like this. That's why we are trying now to implement the regional climate change scenarios provided by our German colleagues. The general trends are that temperature is increasing, salinity is doing whatever it does. It's a little bit more uncertain. Most likely the halocline is getting stronger and the northern Baltic Sea is getting fresher and the southern Baltic Sea is getting more saltier. And then there's also nutrient scenarios. So based on the local activities, the nutrient level might go down or they can keep their current levels. This is the no oxygen zone. So the blue one is following the Baltic Sea Action Plan. So if we are able to reduce the nutrient input to the Baltic Sea, things are getting better. The model that we had, this is just to show what kind of model it is. It includes sea level rise, and also like those 3 nutrient scenarios, it following RE5, and resolution is around 3.6 kilometers. So these are the very first results, just to compare the end of the century to the current situation with the climate and environmental variables. So there's no species included in this figure, just the temperature, salinity, oxygen, phosphorus, nitrogen, chlorophyll, comparing those distribution of the environmental properties locally. So basically, what can be shown already using only the surface variables is that the northern parts are changing more, a lot, compared to the other areas in the Finnish waters. And it seems that there are some spots that the climate change isn't affected as much as in the northern parts. But when we take into account the species distributions, the figure is somewhat different. This is like the mean species distributions when taking into account the surface variables now and then the end of the century. Because of the resolution, this is not showing a lot of details, and most likely it's not the full picture, because you have to ask me in a couple of weeks when I have had a little bit more time to analyze the results, that what is actually showing here. But the main outcomes already with this kind of like robust analysis is that the north is changing, the freshwater species are going to be in trouble, most likely in the future, and also that the major changes are going to happen along the coast where most of the species are. And that's problematic, because in the Baltic Sea, the species don't really have anywhere to migrate, because there's no space left. Their area, they can't go north, there's freshwater there, and the marine originated species, I mean. And they can't go south because it's getting too warm. So it's just like the window where the biodiversity hotspots, or where any species can locate in the future, is getting quite narrow, the area. But there are still some areas that need to, really, we have to make action and protect at least the areas where the climate change affects least. So if we compare the biodiversity hotspots today and where those might be in the future, it looks quite grim. I mean, there are few areas where they don't, like the red color here tells that that's the worst place for the biodiversity to exist. There's most likely experiencing the largest changes. And the blue colors is then that there might also in the future be environmental conditions suitable for the species that we have there at the moment. But again, these are as Fabio said, he did his presentation yesterday. I produced the figures on Tuesday, so this is very new. I'm happy to talk and get some ideas how to process this and what we should do next. But the idea is to produce something similar to this in a higher resolution. Yeah, this is just summary and next step. And I think it's time for the coffee and a few discussions.
Thank you, Katriina, for a very useful set of results. I know that you still are digesting the messages, but any questions or comments for Katriina? Yes, Fabio.
Thanks for the presentation. So do you think that in this context, trying to reduce regional stressors might be more important than, climate-related changes, even if this is not the right Congress to say that?
Well, I can't say it's more important. I would it's something that we can do locally. And reducing the nutrient input to the Baltic Sea is very much, like it's the way to do. It's a way that we can actually save some of the species. And it has some like effect within like a couple of decades. So yes, it's in this context, yes. But we should do everything that is possible to do.
So what you're advocating is basically trying to understand a full system with multiple stressors, with all of the information you have, as much as possible, yeah?
Yes.
Because although
so the like time scale is like by 2030.
Yes.
There should be a lot of information that we can give to policymakers, and that is approaching quite fast.
Okay, but it's still, you're still advocating for a very context-specific set of effects in some of your changes that you are observing, or you still are looking at the results? Is there still preliminary results?
Yes.
Yes, so there's more to come yet as well?
Yes, in a few weeks. If
Okay.
you're interested, please contact me. I just joined Twitter, so you can find me there as well.
Okay, thank you. Any other questions or comments? No? Okay, well, thank you very much. Just before we break for coffee, this is just the first part of our session, so please go and grab a coffee, come back at 11 o'clock, please. This morning, I think it's been really insightful just to talk about nature-based solutions as concepts, examples, applications, context-specific responses. So please do come back at 11 o'clock. We got a lot more to say. Thank you so much to all the speakers and the conveners as well, co-conveners, for keeping to time. And please go and have a coffee, come back with lots of questions, and we look forward to seeing you at 11 o'clock. Okay? Thank you very much.
Hello? Yep. Okay, welcome back to the session. So I'm introducing the next speaker is Stefanie Broszeit. She has changed the title, much shorter than the one in the agenda. So I'm not going to read it because it's there.
Thank you. Welcome to my first episode of Fun with Indicators. What we have done in the Future Mars project was to assess how we can measure the effectiveness of nature-based solutions on climate change mitigation and adaptation. And so we really need to think about selecting the correct indicators to assess their effectiveness and their effect on ecosystem services. So just because we've been here all week, we know that marine and coastal regions provide lots of ecosystem services and benefits to people, but climate change has been identified as one key driver of environmental change. And so this session in particular is talking about the interventions to support these important regions. And my interest is really in measuring the effectiveness of any management strategy. So also, again, a shortened definition of the nature-based solutions. And what I would really like to point out here is that they are solutions that are inspired and supported by nature, cost-effective, and provide environmental, social, and economic benefits, which to me sounds like ecosystem services. And they strengthen the resilience, and that's the European Commission definition. Myron has done a great job in introducing the Future Mars project already. So just briefly, we are looking at 3 particular nature-based solutions, which are effective restoration of key habitats and habitats that will help us to adapt to the climate, effective conservation of key species and key habitats, and nature-inclusive harvesting. This is a concept of the ecosystem services, which is something I've been working on for the last 10 years or so. And just to be quite clear to people who are maybe less interested in this, so you have the environment, and then you have the social and economic system. And you have in the environment are happening all these the structures, functions, processes that then can lead to, to services that we need, such as flood protection or food provision, and that we are very much reliant on. And then there is the, again, and then there is the goods and benefits that people receive from the environment. And in order to measure the effectiveness of any intervention that we do, we need to use indicators. And rather than thinking if there are any new indicators that we can use, we actually have quite a plethora of indicators already. So, for example, the Sustainable Development Goals have indicators contributed to them. IPBES, essential biodiversity variables, the OECD, Eurostat, and of course a lot from scientific research. And this, as one example, is the EU's funded DEVOTES project, which finished a few years ago and which was concentrated on indicators. And I suppose you all have your own indicators that you're working with and that you are aware of, and they are really too numerous to count here. So really, the work for me is about finding indicators that can encompass these three things. So how can nature-based solutions help us with climate change and to produce ecosystem services? So these indicators need to address three key things. And the methods that we used, we had an interdisciplinary team, which were all listed in the title page. We got together to use our expert knowledge to come up with a framework of indicators. And then we had case studies, or as Myron said, storylines, so geographical areas where we know they are using indicators to see if what we have been doing has been useful for them. And no data were analyzed in the making of this indicator list. So it is purely about the framework. The ecosystem services that we were looking at came from the provisioning realm, such as food provision and material provision, regulating, such as disturbance prevention, habitats for nursery habitats for different species, climate regulation, bioremediation, and a few others. And cultural services such as recreation and tourism, aesthetic values, heritage, scientific advances, and education. And the geographic area, again, is mostly focused on lots of different habitat areas in Europe, but also we have a couple in Israel and South America. And the idea of these storylines or case studies is that they're trying to use these nature-based solutions to address local problems or regional problems in their area. So in some areas we might be looking at algal turfs, as Fabio has talked about earlier, or in the Baltic we might be looking at habitat changes to important species and biodiversity. We took a four-step approach. The first one was to create an indicator framework with which we can objectively test all the indicators. And so we used 40 researchers in focus groups. We then used a literature review, looking at the scientific literature, EU reports, and all SDGs and IPBES websites and information to come up with a viable list of indicators that we can use. We selected the indicators that were relevant to those areas that we are studying. And this was done by all authors of this publication. And then we asked the storylines or the case studies to assess this by asking them to fill out a survey. So never show tables in a presentation, and this is basically all I do all day, so bear with me. But basically what I'm trying to show you here is that the framework itself is so big that there's no way I can get it on 100 slides and show you. So we've split it into blocks of information. At the beginning, we have the background, the name, the title, and where the indicator is coming from. Then we link it to the ecosystem service classification, for which we used CITES, the Common International Classification of Ecosystem Services. We linked it to social and economic benefits. So to see how it goes all the way through the system, from biodiversity to the economic benefits. We had a list of different criteria, such as the scientific background and relevance and the capacity to address climate change. We had a quality control assessment. Again, this was done through the literature review, so we didn't test any indicators. We let the literature guide us on that. We linked it to policy through societal uses and a bit of data location. Because we were also looking to see if there's data already available. Again, another advantage of using the system, because the data is quite often already there. So just a few more results. So we found 201 indicators that we thought were relevant, and we split them into pressure indicators, biodiversity and environment indicators, response indicators, which is basically any EU directives or policies or any other policies that are managing the marine environment, economic and social indicators. And then we split them into the 3 categories of ecosystem services, which is why the sums of them are a little bit higher than what we have, because quite often you can use one for several ecosystem service types. The pressure indicators, we had 7 groups. So pressures were fishing, invasive species, pollution, nutrients and deoxygenation, and fishing, or physical effects of physical on the marine environment. And we did not link them to ecosystem services because, of course, if you have a pressure, it can affect all of them. And then we checked the applicability with the storylines or the case studies. We had 27 of them who replied, and we found that they used 70% of all the indicators from the framework, and that the biodiversity indicators were used the most heavy. Then we had quite a good number, 17 out of 24 of the economic indicators, and not so many of the social indicators. So we've now submitted the paper that describes this whole process. And for the moment, this has really been a snapshot of what we have been doing. And it allows us to assess ecosystem services from biodiversity to economic and response dimensions. And we've also seen that it's used in the real world, so to speak, by asking our storylines. And we realized that the biodiversity indicators were firstly more numerous and also more used across the storylines, while, for example, the social indicators were not so. So we think there is a bit of a mismatch that could be addressed by looking at which indicators exactly are used for which ecosystem service, and to see if we can suggest indicators to researchers so they can make the link all the way through from biodiversity to social and economic information. Thank you.
Okay, thanks, Steph. We got some time for questions, if any. So otherwise, I would ask, why do you think that social indicators were not so appealing or used, probably?
There were several reasons for it. I think that the focus in those case studies was more on the biodiversity, and that the social indicators are being used to a lesser extent, but the ones that are used are really important for understanding the social. We also think there could be several reasons. We also think that historically there's probably better work on indicators in the ecology, biodiversity research than in social and economic research, which is why those gaps are coming up. But we are still assessing more. We are going more into depth. So yeah, keep your eyes peeled on the research, because I think there's a lot more we can say out of this work. Thank you.
Any other question? No? So I guess yeah, we still have a thanks, Steph. Our next speaker is Kristin Kleisner. Sorry, I'm just messing up. So the title is Evaluating Blue Carbon Natural Climate Solutions Across Climate, Ecological and Socioeconomic Dimensions. Please go on.
Thank you.
The floor is yours.
Yes, thanks all for being here. Thank you, Jack, for a great talk, which I think really relates very well to mine, which is on natural climate solutions, which is a component of nature-based solutions, Myron. And I just want to thank my co-authors, as well as many others who were involved in this work, which I'll talk about here. So what I'm going to do is give you a little bit of background on why natural climate solutions are so important. I'll present some of our evaluation framework to understand a suite of blue carbon NCS, which includes open ocean or offshore blue carbon. I'll present some of the key findings, but this is an ongoing work, so I'll talk a little bit about next steps as well. So this graph has been shown quite a bit at this conference in other sessions in the Beyond Blue Carbon and a few other places, and really there are a number of actions that are going to be necessary to keep the global temperature increase below 2 degrees or ideally below 1.5 degrees by mid-century, and that's in addition to the use of renewable energies and conventional abatement technologies. And so one thing, the main thing, is that we're going to need a precipitous decrease in greenhouse gas emissions, and that's what's in the beige in this figure. The second thing is that we're going to need our carbon removals and uptake by natural systems, and that's in the dark blue. And then the third is that we're going to need the development and the deployment of technologies that result in carbon removal technologies that can result in the continued drawdown of CO2. And all of the IPCC scenarios, regardless of what scenario they were looking at, noted that natural systems are going to be key in the solution. So I just wanted to note that carbon dioxide reduction, CDR, is a spectrum of approaches, and you can really, the spectrum is defined by how much tinkering we're doing to the environment. So on the right-hand side, we have those more tinkering, heavy manipulation of the system, the ocean physics, the biogeochemical processes, so negative emission technologies. And on the other hand, you have the more quote-unquote natural climate solutions, where these are strategies that aim to avoid greenhouse gas emissions or sequester carbon from the Earth's atmosphere by protecting, managing, restoring, or enhancing ecosystems. And I'm going to focus on this end of the spectrum here. So what is blue carbon? So blue carbon was a term coined in 2009, and for about the past decade or so, it's referred to the carbon that's sequestered in vegetated coastal ecosystems, specifically mangrove forests, seagrass beds, and salt marshes. But more recently, that definition has been expanded to also include other systems, including seaweed cultivation or farming and open ocean systems. And in the open ocean, as Jack noted, we're talking there about really the role of marine animals in driving the carbon pump and in bottom disturbing activities like mining and trawling. And Jack, we should talk because we have some work that's actually better estimates of how much carbon actually reaches the surface from these activities. So a couple of years ago, about 2 years ago, EDF received some funding from the Earth Fund to look pretty comprehensively at natural climate solutions in the ocean space and really evaluate what we know and what we don't know about these different pathways. And the way that we did this was to convene a bunch of experts that ranged, in their disciplines, everything from biologist, ecologist, biogeochemical scientist, people who know a lot about the rates of things sinking in the ocean, on over to those who are, more on the social science, economics, and policy experts. And we held workshops, and they were siloed by nearshore, seaweed, and open ocean, just because these systems are different, although they're all interrelated. And together, these groups of experts worked to build these conceptual maps that looked at stock and flows in the system, but also interconnections, and really to try to understand what are the climate, the ecological, the socioeconomic benefits, because we were talking about natural climate solutions. So of course, these are generally thought of to be good things to do. Beyond the climate benefit, they offer many co-benefits. We also wanted to understand, though, any risks that were inherent along these dimensions, as well as feasibility of implementing these solutions. So what are those sociocultural, political, or governance limitations, and how can we leverage these pathways at scales that could contribute significantly to global decarbonization, at the gigaton scale. So in terms of readiness, our definition was expansive. We were looking at, there's a lot of interest in carbon crediting, but in the ocean space, we didn't want to use that lens exclusively, because I'd argue that, and several talks have shown that not all of these solutions are ready for prime time for carbon crediting. There's a lot we don't know in the ocean space, and for carbon credits, you really need really strong monitoring, reporting, and verification. So on that blue arrow, the climate potential, things like the magnitude, the permanence, leakage, additionality, and those sort of MRV protocols, they are difficult to measure, which I'll show. So we also included in our definition of readiness, how these actions could contribute to nationally determined contributions that countries are making under the Paris Agreement or sustainable ocean plans, for example. We did look at these ecological potential, so effects on habitats and biota, socioeconomic potential, jobs, the distribution of benefits, and then again, feasibility. So in the coastal blue carbon, and I'm just going to talk about coastal and open ocean as bookends just because of time. And so our coastal blue carbon interventions, we were looking at seaweed beds, seagrasses, tidal marshes, emergent tidal marshes, and mangroves. And we were looking at the interventions here were either conservation, which is an avoided loss strategy, or restoration of these ecosystems. And I did order them in the way that the experts felt that they were, held more climate potential. So you'll see mangroves over there on the right. And that was generally because in terms of extent and mapping, a lot more has been done on mangrove systems. They've been more studied. We have pretty good estimates. But these other coastal ecosystems have much less certainty, and that's primarily due to limitations with remote sensing. But there are other things that the experts noted in terms of what we need to reduce the research gaps. So first and foremost, more accurate estimates of net radiative forcing. So what we mean there is it's not all about the carbon that's sequestered, it's also about the greenhouse gas flux, and particularly in systems like mangroves, seagrasses. That is an incredibly important part of the equation. You could have other potent greenhouse gases that are being released, like methane, that counter or offset the carbon mitigation, or the carbon sequestration. We also need improved predictions of climate change impacts on carbon sequestration. We know that coastal ecosystems are heavily impacted by many things, climate change included. There are more frequent coastal storms, saltwater inundation, sea level rise. There's also the migration of these ecosystems and coastal squeeze. And then there are and these all have an impact on how long that carbon in those systems can be sequestered and whether it'll be re-released. We need better quantification of the ecological and the biogeochemical linkages. So we know that these are ecosystems in and of themselves, and that's very important, but they're also obviously part of the marine ecosystem, and so they're connected with coral reefs, and so coral health is important, but also upland systems and the open ocean as well. So there was a lot more that obviously we learned about the social and the economic side of the equation, the ecological, but I'm just presenting a snapshot here. On the open ocean side of things, we were looking at several very different sort of pathways, and Jack mentioned whales. Whales have been getting a lot of hype, I would say, lately. Rebuilding whale populations was one pathway that we explored with the experts. Limiting bottom disturbing activities like trawling and mining. We looked at managing fish for their carbon value. So that is really thinking about fish that we exploit now, and many of them play a very important role in carbon cycling. And so how do we think about our management that would actually value that role in particular? And then we looked at mesopelagic fishes as their own pathway, because these are fish from about 200 to 1,000 meters in depth. They're not commercially exploited in large extent right now, because it's not commercially viable, but there's a lot of interest, I would say, in exploiting them, and Renato's talk highlighted why, and that is that, as fish meal becomes more scarce, people are looking at mesopelagic fish as a sustainable replacement for fish meal, and they have an incredibly important function in carbon cycling. So, in general, the experts found that none of the open ocean natural climate solution pathways were yet mature enough to provide high-quality carbon credits. But we put mesopelagics on the right there because they felt that there could be some efforts there that make them ready for near-term implementation. And that has a lot to do with the fact that there's a large magnitude of these fish out in the water, and they drive a large part of the carbon flux. And on the low end, it's huge. So we're talking a big range in terms of the unknowns, but on the low end, gigaton scale. There's a lower risk of adverse impacts. It's probably a good thing to do. They play an important role in the ecosystem. They also felt that the science surrounding whale carbon was most in need of further research. Some quick findings here. So across all of the open ocean pathways, generally the experts thought that they were scalable, but the science was incredibly underdeveloped. So really copacetic with what Jack found in his survey. There's also substantial MRV challenges. These are large spatial scales and large biogeochemical processes at play. Manu Di Lorenzo's talk a couple days ago in the Beyond Blue Carbon did highlight the work of WHOI and their work on a 4D ocean observing. That could help plug the gap there. Sustained direct observations are difficult in the open ocean, and also this idea that mobile species like fish and whales, it's really hard to attribute carbon sequestration to a particular EEZ or group of people. And then I won't go through all of these, but the general gist is that we need more quantification of carbon export. We need more modeling. We need estimates that we can plug into models. A lot of the experts felt that, there was a division, but there were experts that felt that modeling was going to be a really important part of open ocean solutions. So observations and models is the takeaway here. And then the next steps, so we have designed a blue carbon survey as well with some colleagues from Clark University. We are going to deploy the survey next month. And if you are working in the blue carbon space and you think we might not have reached out to you, we would love to. So please reach out to me. We'd be happy to have you take the survey and also talk to you more, because we're doing some actor mapping to try to understand these pathways. And so that would be great. And the ultimate, what we're trying to do is really quantify the results and work to build some consensus in the community around which ocean-based pathways could be closer to ready for implementation, require more research, and really identify what those research needs are, or pose some substantial risk to people and nature. So I will take any questions if there's time. No. Thank you.
Thanks, Kristin. It's nice. There is time for questions, if any. I would have a couple, maybe just one now.
Okay.
Could you comment a little bit on why the risks for mesopelagic communities would be lower in terms of?
So the intervention was looking more, I should have been clearer on that. So it was more of a take a precautionary approach. Even, there was some discussion of, do we wait and have a moratorium, like don't fish the mesopelagic until we know more about the risk to disrupting the carbon flow. And so looking at that particular intervention, and that would be the action, the experts felt that's relatively low risk because they're not fished right now.
Yeah.
Sorry, wasn't clear.
Perfect.
Cheryl Harrison, LSU. So I've been wondering about how mature the modeling is around blue carbon under different future climate scenarios. Like, do we know how mangroves and salt marshes are going to change in their ability to survive at certain latitudes, or their ability to hold on to their carbon? Is that a well-developed field?
That's a great question. I think there's a lot more work to do there. And so I think, it's a good thing to do, obviously, to conserve these systems or these ecosystems where they are. Restoration efforts, though, I would say should be take into account these, the effects of climate change. And I would say that in what I've seen, it's not across the board that that's always accounted for. So I think we could do a better job there.
Okay, thanks a lot. Time's up. Thank you very much. Our next speaker is Silvana Birchenough. It's going to talk about sustainable harvesting of commercial species in the Belize Exclusive Economic Zone.
Thank you. This chair is very active, I tell you. I had a question, but I will pick it up afterwards. Thank you. Yes, so another case study from the EU Future Mares. Today I'm going to take you back to the Caribbean. This is a real, true collaboration between, obviously, colleagues from the Future Mares and also our colleagues from the Belize Coastal Zone Management Authority and Institute. They have a dual function. They monitor the coast, but also the shelf area of Belize Coastal Zone. But also they work in partnership with a lot of conservation agencies and a lot of the fisheries department's activities. But also, just like to acknowledge my collaborators, Andrea Rosado and Arlene Young. They are extremely active, and they also join a lot of the online meetings with Future Mares. So there is a lot of knowledge transfer here, as well as learning from each other, which is really valuable. Just to begin, thank you very much to all of you that already introduced the concept of nature-based solutions. I'm really grateful that this has already been covered. But today I want to just literally cover the story 38, which is here in the Caribbean. We have two different elements of the work. Today I'm only going to present one just for the completeness of time, but also just the elements of the work we're doing at the moment. So this is about nature-inclusive harvesting, which is another element of the Future Mares storylines. So not only we cover effective restoration, which you've heard a little bit today, but also the effective conservation. So this is another piece of the puzzle, as you see here. And just to put things into context, Belize is a place where I've been very lucky. I've started working there since 2015. So I've looked at several elements of Belize and Belizean issues and challenges, but nevertheless, it is a really fascinating place. As you see here, obviously the biodiversity of the place is fantastic. Species and habitats are there, from coral reefs to mangroves to seagrasses to sand, commercial species, iconic species. But also a lot of people in Belize rely heavily on the fisheries, but also the tourism. Those are the two main activities. And also, it's a clear place that generation through generation often don't leave the island, and you can see why. And people look like this all the time. They're always naturally very happy all the time, every day. And you see a lot of, obviously, iconic species like turtles and some of the whale sharks. But also the place is very interesting for diving as well. And also commercial species, the lobster, spiny lobster is a very important species, as well as the conch, the queen conch. And the idea is that trying to understand a little bit of the diversity, but also use this information into context to generate the understanding for sustainable harvesting with the nature-based solution context, of course. So just to begin with,
Belize Integrated Coastal Zone Management Plan has been gathered over many years. It's a live print document. It's very much generated with new information. And it was really interesting when I got there, they just finished drafting the management plan. So immediately they sat you down and said, what are you doing? What are your intentions? And how are we going to use your data and your knowledge? So I said, yes, that's fine. We can share a lot of the information. But also there's always elements, because they are evolving all the time. They always want to collect new data, new information to augment what they're doing for the coastal zone management. So it's a very active plan, and I will show you some examples how they engage not only with the locals, but also with the schools, with end users of the spectrum. So it's really interesting how they very proactively push conservation, but also management strategies. So just very quickly, just to show you a little bit of example, as I said before, coastal zone management are the ones that call the shots here with all of the stakeholders. On a quarterly basis, they look across all of the stakeholders, who are the persons that need to be there. So as you see here, they divide the regions. So this is Belize City here. This is where they're based. They divide the regions into northern, central, and southern Belize, and they very thoroughly go through all of the details of the areas from, for example, the activities and the sectors that live within areas like this, but also they divide very much into 4 areas of geographical, biological, administrative, and economic similarities. So not only they actually illustrate individual areas, but actually they bring together a lot of the knowledge and interlink. So trying to really collocate activities as well as engaging into the planning, into the assessments as well. And as you see here, Belizeans are very renowned for having lots of breakfast meetings. They like to talk very early in the morning. So they go there and they sit there and they talk about coastal zone planning, which is fascinating. So just to give you a little bit of example in terms of the marine protected areas, we've heard a lot about marine protected areas. Here's the diagram of all of the Belizean marine protected areas. We have different color codes here because a lot of the marine protected areas started back in 1980s, so they're very active in terms of conservation, but they know exactly what they want to do. But a lot of the blue areas here are areas where they are management areas. They actually are working some of these areas. The red ones are no-take zones for obvious reasons, so they are protection of habitats. But actually, they are very active in terms of implementing the fisheries management in Belize. So not only the fishermen have a quota, but actually they check on the gear, they check on the uses of the gear, but also they see these fisheries management tools not only to generate livelihood and work, but actually also to preserve some of the environment. So it's really nice how they work around and how they actually protect, but also use this as a work in marine protected areas, which is quite interesting, the concept, because how can you protect if you're actually there fishing or extracting or doing ecotourism? And they do it very responsibly. So they do manage that conservation aspect, but also the resources themselves. So the new aspect now, the moment that we are talking about and we're working towards, is the climate resilience and the aspects of food security, because they do acknowledge that there has to be a livelihood, there has to be jobs, but also climate is also a very strong pressure on the island as well. So in terms of the fisheries themselves, they have many, many species, but majority primarily, you see here the spiny lobster and the queen conch. So here are the landings of conch in red. As you see, they've been very, very successful until a period back in 2015 when the landings are starting to decrease. And this continues to decrease a little bit further, so the quink is really suffering. And the lobster has the opposite peak. There's been very active being harvested lobster, but now at the moment, obviously the lobster seems to be coping a little bit better. Crustacean, again, I had the luck to look at all the further stressors, so temperature, pH changes. Lobster is actually better equipped and they move faster as well. And they have areas where they actually come into the nursery ground. So lobster is doing a little bit better than conch. At the moment, as well as that, and you can see here the fishing grounds, they have very organized 7 fishing grounds here. A lot of the activity happens here, very much close to Belize City, because the cooperatives are just here and here. So they have very successful ways of dealing with the catch, but also bringing the information together and being able to export, because they are very, very good on business. Another piece of work ongoing is the climate vulnerability assessment. Again, is ongoing on the 2 species, but also on the other species of importance, which are the red snapper and the mahi-mahi as well. But this is another work that is still happening. But nevertheless, as well as that, the in terms of sustainable harvests, another aspect which is really relevant and important, as we heard before, a lot of these areas have the presence of invasive species. Lionfish here is something that is happening a lot in the Caribbean. In Belize as well, the fishermen are looking for sustainable options, so they are trying to really bring the threats to actually support an opportunity. And the saying is that if you can't beat it, you eat it, and they do eat it. And you can see here people really out there, fishermen just spearfishing, catching it, and actually selling it in between all the catch. So this is the catch that comes to the cooperative. As you see, they are very proactive, and in between also they're starting to bring the lionfish as well. At the moment, there is a lot of assessment in terms of coral reefs. We're looking at some of these habitats to see not only the distribution, but the numbers of lionfish, and the numbers are increasing substantially. So it's something that, again, we're looking into the areas that we can actually support. Another aspect here, and I'll tell you more in a little bit as well. So looking in terms of the challenges, as I said before, the area is extremely active. As you see here, we have a lot of habitats, so the MPAs again are here again, but also we have a lot of areas where we have algae-dominated habitats, we have seagrasses beds, we have obviously the plain sand around as well, important for blue carbon, but also we have extensive areas of coral reef, and then obviously a very clean water. But also, as we're starting to look at some of these risks, we're starting to look also not only offshore or the coastal area, but also we're starting to look at the inland areas. You see here, this is a risk base that was done a year ago, where we look at what are the main activities, what are the main risks. So, for example, for Zone A, which is the green area here, we have a lot of flooding, we have a lot of changes in very abrupt temperatures, which again, it comes from land, but it actually does transfer to the coastal area and to the shelf area as well. But also we see a lot of the areas here and here where we have, for example, hurricanes, extreme events. We have, for example, saltwater intrusions, because we have riverine instructions as well. And we do have aspects where we have a lot of variability, so aspects of acidification as well are happening in some of these sites on the more coastal side. And warming, of course, temperature is also a risk. And as you see here, the other recent challenge we had last year was Hurricane Lisa. So it resulted in a lot of disruption, but also in a lot of the floodings. And you see here, Belize was like that in the weeks of October, so everything was flooded. So it was quite extreme events that caused a lot of challenges to the community, but also we were there a week before, so it's quite interesting how people actually are preparing to go to shelter. So again, it's another aspect of complexity in some of these islands. But nevertheless, we managed to do our questionnaires and our workshops. We worked really closely with some of our colleagues. We were asking about main challenges. Of course, the hurricane was something that they were aware already, so they told us immediately that was a challenge, but also how they adapt to some of these challenges and how the actual marine spatial plans, they have a new revised marine spatial plans, are looking at climate adaptation, very actively looking not only for sources of integration, but actually what does it really mean for the activities themselves. We talked a lot about new data requests, new data sets that they would like to bring together. They have a lot of information, but again, as always, it's very patchy. Many people come and do lots of studies, and then you have to kind of bring things together. But actually, one of the things that we're doing for Future Mares on the climate work that we're doing is bringing all of the local studies with the model data, so that will help us for our climate assessment, which is really good. So we'll have the wider scale information. But also we talked a lot about, in terms of internal, what does it really mean for them? How are we going to integrate with the new resources? How the fish will actually, the fisheries, not only just the commercial species like the lobster and the conch, but what is it really yet to come? So the new opportunities. So the lionfish was one of them, but mariculture is another aspect that they are very keen to develop. For example, lobster mariculture and lobster tagging. So as well as having different options when the conch fisheries close, the lobster will reopen, and they're looking at options to expand this. So we talked a lot about some of the areas in the deeper side of Belize of the shelf, which again, they don't know anything about it, but they think that they could have a fishery. So again, looking at new opportunities, new technology that we can bring, not only to support what they already are sustainably harvesting, but actually what is it really for the future applications. So we talked a lot about options of seaweed aquaculture as well, of course, but also diversification of activities. These are the kind of things that they're really keen. Some of the fishermen, they naturally become tour operators or ecotourism because they can dive, and they're very keen to showcase the knowledge. So as we continue to bring some of these considerations. The cooperatives play a fantastic role and a very key role with the regulators, which is very new for us, the concept, because they are discussing all of the marine spatial plans, but also as they close in some of these areas, what is going to be really for them for the new opportunities, and they really push as a sector. They just have a lot of power. But also the lionfish is something that potentially could actually be a species that they could release as a fishery and harvest this species. So that, again, is something that they are discussing and they are pushing. As I said before, the climate change, we're bringing together this knowledge that will help not only to understand, but actually to bring active information into key documents. So I think future matters will make a very distinctive difference to Belizeans as well, and their harvest and their resources. But also we have a new ministry, the Ministry of Blue Economy, which again is looking for exploration, so the deep water assessments could actually be something that in the longer to medium term could actually happen. So we are talking about new habitats, new fisheries, and also bringing some of the educational capacity. A lot of the new generations are very keen and very eager to know what is it really the sectors that they could go into it as they grow as a professional, as a young professionals. And also we talked about new of the atolls as well. They are trying to bring new tourism opportunities. They're still yet to come, of course, but there are a lot of island complexes, and dredging is one of the activities that they are concerned because of the resuspension of sediments and some of the current challenges to existing habitats. So a lot more to come, but nevertheless very exciting, and we are bringing a lot of the concepts from UMAR's nature-based solutions and sustainable harvesting to this work. So with that, I think just about time. Thank you very much. Thank you for listening.
Sorry, there is no time for questions. No. So we go on with the last speaker, Michelle Staudinger. A novel approach for assessing territorial biodiversity in anticipation of coastal adaptation projects and climate change impacts. It's coming up.
Well, thank you everyone for staying for the very last talk of the session and the day. Although I'm the last talk, I think the information I'm presenting today should be considered a first step to any nature-based or any other coastal adaptation project scope of work. And even though I'll be focusing on a particular habitat and place, I think the approaches that I'll present are easily transferable to other coastal habitats and other places. So this study takes place in the Boston Harbor Islands National and State Park, which is located in the Northeast United States in that white box. And our focus is on the series of islands outlined in the blue box, which are all located just east of the city of Boston. Now, the Boston Harbor has had a long history of human impacts. In the 1900s, the water quality was so poor and it was so polluted that it earned the nickname Harbor of Shame. But with some concerted conservation and restoration efforts, it is now a successful model of conservation. The series of islands is the only coastal drumlin archipelago in the United States, and they're comprised of glacial remnants that support a wide range of socio-ecological resources, including biodiversity, which I'll be focusing on today, but it also supports recreation and tourism from nearby Boston. This is also an urban park. And the islands themselves provide protective ecosystem services, again, for the greater Boston area, making them incredibly important in the face of sea level rise and in rising coastal storms. So the Boston area is considered a hotspot of sea level rise. It's already experienced about 1/3 of a meter of sea level rise over the last century, and we are expecting anywhere between 1 and 2 meters by 2100. And so for these reasons, last year, the Boston Harbor Islands was named one of America's 11 most endangered historic places due to the threats of sea level rise, warming waters, and non-native invasive species. So the National Park Service and their partners manage this park, this urban park. And the National Park Service is a great example of an organization that has a mission to support human well-being through nature-based experiences for the public, but also has a mission to support biodiversity on public lands. And so the NPS and their partners are considering a range of coastal adaptation actions, including nature-based solutions, to bolster the Boston Harbor Island shorelines in the face of climate threats. And in a lot of places, they're calling this experimental manipulation of the coastline. And so this project is really seeking to take a balanced approach of developing strategies to help protect and adapt park lands and waters in the face of climate, but is also hyper-focused on understanding how biodiversity could be affected, and we're developing protocols to track abundance and diversity of species in the park. So the focus habitat on these islands is called mixed coarse substrate. This is defined as substrata consisting of rocks, boulders, cobble, gravel, shell, and sand. No one substratum greater than 75% of the surface cover, no less than 50% cover by rocks or boulders. And while mixed coarse substrate habitats are common across the park and other areas across the region, this habitat currently lacks a standard and repeatable biodiversity monitoring protocol to reliably track changes, either natural or anthropogenic, over time and across locations. And so this brings me to our study goals, which was to first synthesize data on the historical intertidal biodiversity and habitat distribution on selected islands with these mixed coarse substrate habitats, and then develop species lists for all the potential species that could occur on these islands and be affected by coastal adaptation projects. Develop watch lists for emergent non-indigenous species, which I'll be referring to throughout the rest of this talk as NIS, and lists of prioritized species as targets for monitoring before and after projects are implemented. So because there was no standard repeatable monitoring framework, we've been in the process of developing that specific to this habitat type, and then looking to use that protocol once developed to collect baseline biodiversity at key sites of interest to the park. So this slide outlines the approach we're taking in this project, and I'll kind of step through this. This is an outline for the rest of the talk, starting with how we developed an occupancy list of species in the Boston Harbor over time. And so the first step in this process was to do this total biodiversity synthesis, and we began by synthesizing 14 different data sets that are comprised of expert-led park assessments, citizen science and museum collections, as well as state and federal agency surveys. And so that led us to develop this first starting point, and as you can see from the graph on the left, the cumulative species discovery curve for the Boston Harbor from 1861 through 2020 included a total potential species of 452. And when we look at that broke down by major taxonomic groups, we see that our intertidal invertebrates and macroalgae are our two most diverse species groups, followed by sea and shorebirds, fishes, and marine mammals. And when we look at the species accumulation curve from this data set, we see from the Chow jackknife estimate that there's a potential for another 175 to 300 species to be found if we continue to sample this environment. Previously, this habitat type that I've been talking about has been considered sort of a biodiversity deficient habitat, and clearly that's not true. So we're using a variety of biodiversity metrics to then characterize and use that occupancy list with. But as you might imagine, pulling together all those different data sets, we don't always know the degree of sampling effort, and so that makes calculating certain metrics quite problematic. And so we found and are using this sampling effort independent metric called average taxonomic distinctness to help us understand species distributions over space and time. But I'm not going to really go into all those results. We're going to move on to talk about the NIS watch list and impact assessment. So this is a subset of the data that I've already shown you, which is showing that of those 400 plus species, about 54 of them are considered non-indigenous species that have been already detected in the park, with most of those detections happening in the last 20 years. And so, as you just saw in this video, some of them are very well established. This is the Asian shore crab, and my students knew that they were under that rock because they could hear them. There were so many of them before they lifted it up to even look. So once we know, so one perspective is we know what's there. So the next step is what has not yet established but is anticipated due to warming and other disturbances. So this NIS watch list that we've developed includes range-expanding species, as well as species introduced from other regions. And in addition to the species name, we collect information on biological and ecological characteristics for each species, as well as the date and location of the last recorded observation of that species in nearby areas. So that gives us timelines of anticipated arrival and helps let us know when we could expect those species to be in the park. And so this watch list that we've developed includes an additional 54 species from the 54 that have already been detected that we are now considering in an environmental and socioeconomic impact analysis. So this method was developed by Hawkins et al. And then expanded by Henry and Sort. And what it does is it provides a gradient of potential concern for management actions, ranging from minimal concern. So this might be, oh, we've detected this species in the park, but it's no big deal. We'll just accept that it's here and maybe keep an eye on it, to massive, which means that it could have a major influence on the ecosystem in terms of the values of the park. And in that case, we might consider actions, management actions that look to stop the spread and eradicate that species once it's been detected. And here is an example of that species that you've already seen, the Asian shore crab, and an example of some of the information that we've pulled together as part of that impact assessment. And so here I've highlighted one source that says that it would have major impact, environmental impact due to its impacts on native crab and shellfish communities through competition and predation. So lastly, we wanted to develop a conservation prioritization list. So first we got rid of the NIS species because we don't want to conserve those, we want to get rid of them. And then with the remaining species, we evaluated their conservation ranks as well as their climate vulnerability. And we did this using a variety of conservation frameworks, including the Federal Endangered Species Act, state threat lists, as well as the IUCN Red List. And then we compiled information from climate change vulnerability assessments, as well as conducted a literature review on species-specific thresholds to sea level rise, coastal storms, and other climate stressors. So this is one piece of the results of that analysis, and basically the take-home here is that more than half of the species that we evaluated had no information on their conservation threat status or climate vulnerability. So that's outlined in that 256 number, and only one of our, there was basically like nothing on the left-hand side of this matrix. When we look at those results by the major taxonomic groups, the species on the left here are species which we did have information on in terms of their conservation ranking. And these are species that include things like sea and shorebirds, fishes, and marine mammals. Whereas the larger bar is all the species that were data deficient, and that is largely almost all of our intertidal invertebrates and macroalgae. So the good news is that our highly ranked species, we already have reasonably good monitoring programs in the park to track them. The bad news is all of these habitat forming and food species we have very little information for. And so this result pointed us to moving forward with designing a monitoring framework that maximized detections of all the potential invertebrates and macroalgae we could possibly see. So this slide is just to remind you that we started with this very broad biodiversity approach, but we're now focusing in just on those intertidal invertebrates and macroalgae. And so what we did was we looked around to standard protocols that were implemented in other sort of similar habitats to the mixed course substrate, things that are typically used in rocky intertidal. We ended up whittling down a list of about 10 protocols to 3. And then we tested those 3 different protocols side by side in the field last year using methods like transects, quadrats, and point intercepts. And then we tested additional methods that might have lower effort or resource needs, such as environmental DNA photoquads and image analysis that could be done outside of the field in the lab, as well as crab trapping and swaths to fill in gaps from those other methods and biases from those other methods. And then we tested these methods at 3 site types across the park. The first was cultural sites of interest to the park, as well as sites that were already experiencing high erosion, sites that we had pre-identified as potential biodiversity hotspots for a number of reasons, which I can explain perhaps later, and control sites. So these results show the results from 1 season at 1 island of sampling, and you can see that we doubled the number of species detected in this habitat, and we also, compared to the remainder of the time series, and we also broke that down by native and non-native species. And so we're finishing to finalize that protocol and then implement it to collect baseline data this summer. And so just to wrap up, a key principle of climate adaptation is to avoid maladaptation. And since biodiversity is a desired ecosystem service to sustain, we really want to think about that very carefully in the design and implementation of nature-based or any other coastal adaptation action, because it could have unintended outcomes if we're not careful. So this project really tried to assess biodiversity from multiple perspectives. We used a historical perspective to assess what we risk losing, a future outlook to anticipate what's coming, and then use baseline data to measure changes. And another lesson learned was that past survey effort and extent may not tell us everything that is potentially there. And then I wanted to just close with saying that our intertidal invertebrates and macroalgae are highly underassessed for conservation purposes. And at least in the US, if they're not listed on some conservation framework, we have little to no authority to consider them in project permitting and development planning processes. And so we might then choose to consider the trophic links between these data deficient but habitat forming species and the more charismatic macrofauna that use them for food. And in this example, I'm showing that red knots use blue mussels as a key component of their diet. And so with that, I'd like to thank my wonderful team. And I probably don't have time for questions, but I can always talk to you afterwards. So thank you very much.
Good. Thanks a lot. Thanks to all the speakers. So please join me in thanking all of them for this fantastic session.
Yeah, so I let my conveners do all the work, so I thought I would quickly tell you the wrap-up points. High-level definitions of nature-based solutions differ, and this was highlighted in the variety of presentations. Presentations covered a broad range of habitat species, ecosystem services, and societal contexts, where information on the effectiveness of different NBS, such as MPA's habitat restoration, was evaluated to address the biodiversity and climate change crises. Knowledge gaps on historical changes in local, my computer just died, contexts, such as losses and gains in biodiversity. Measurements of blue carbon benefits need to be addressed to help plan effective NBS and gain realistic expectations of potential climate, biodiversity, and social benefits. And last but not least, examples of NBS applications and analyses also highlighted the importance of socioeconomic assessments, participatory needs, co-development, as well as the evaluation of the suite of co-benefits. So I would like to thank everyone who contributed to this session, my co-conveners, and sorry for kind of moving into lunch a little bit, but I had to develop these before the end of the session, so I'm sorry if I didn't hit all the points that the speakers made later in the session. So thank you very much. Enjoy another great lunch.